But what makes machine learning uniquely challenging into production? We have several set of reasons, and we're going to highlight those through this talk. Starting with the first one, which is mainly dataset dependency, we have mentioned three here. So there is, on the first hand, the famous black box of machine learning, which takes lots of inputs, be it algorithmic, human dataset to provide input. But there's also the lack of reproducibility and having correct results as input. Uh, Data changes over time. The data is significantly changing, so there's always a difficulty to have the same results over and over again. And because live data is different than to training data, machine learning in production usually tends to behave differently than in the developer sandbox we have seen previously. Then moving on to part two, which was simple to complex practical topologies, we have seen some issues as multiple loosely coupled pipelines running possibly in parallel with dependencies on human, the future engineering must match for training and inference as well, control pipelines, A/B testing, complexity with the different techniques of ensembling or federated learning, etc. So as much as it goes to more complex topologies, machine learning deployment in production becomes more and more difficult. Part three, heterogeneity and scale. So today we're having lots of engines, lots of tools, lots of interesting technologies out there that are being born, I would say, even month after another. And we have possibly differing engines like Spark, TensorFlow, Caffe, PyTorch, etc. And on the other hand, many different languages like Python, Java, Scala, and R. And all these are being used, and it's significantly heterogeneous. So we are noticing issues in inference versus training engines. Like training can sometimes can be frequently batch, inference can be REST endpoints, custom code, etc., future manipulation as well. So each of the engines mentioned previously comes with a set of features and opportunities, but also have many issues that have to deal with, and integrating all this is not easy for in production. Then there's another part which is also important, and we don't usually talk about this part, although it leads most of our initiatives and projects today. It's compliance and regulation part. And through the years, there has been efforts for the regulation and the compliance, and we have, especially in the financial services, be it banks, insurances, etc. It was really important to have some kind of risk management models or regulations to in order to protect the financial institutions. Or for example, we have also the GDPR on reproducing and explaining machine learning decisions, and until recently we have been delighted to see an initiative of the European AI Act that was trying to have more regulatory, I would say, context for AI and limiting the use of more high risk applications. So these were major parts in problems for that are challenging machine learning into production today. Another part was collaboration and process. So for the collaboration part, the expertise mismatch between data science and operations definitely complicates the integration and the management of the applications we're developing today. So there's not really a big collaboration or a suitable way to approach it. And there's also problems in the process. So many objects to be tracked and managed. We have many algorithms, many models in the pipelines, many versions of the code, etc. Machine learning pipelines are code, so some approach them as code, some not. Depends how people see them. But also some machine learning models objects are not best handled in source control repositories.